Alpha Centauri, a system of mystery. Alpha Centauri is not just a single star but a system filled with complexities and wonders. It contains three major celestial bodies. Alpha Centauri A is a star very similar to our Sun, and it is officially known as Rigil Kentaurus. The second star in this system is Alpha Centauri B. It is also called Ptolemy, and the last one is the mysterious Alpha Centauri C, which is also known as Proxima Centauri. It is a red dwarf which orbits around these two at a distance of about 0.2 light years. A lone wandering star which is right at the edge of its stellar family. Proxima Centauri has a secret, a planet called Proxima b. It was discovered in 2016. This rocky exoplanet is very close to its star, at just 0.049 astronomical units away, yet it is still in Proxima Centauri's habitable zone. So, could this be a second home for our human civilization? Is it possible? Or are there conditions here that will forever keep this planet shrouded in mystery? Proxima is also our closest known exoplanet. At just 4.246 light years away, in cosmic terms, it seems really close, but being this close has its own implications. A distance of 40 trillion kilometers. This is such a vast distance that even light, which is the fastest thing in the universe, even light takes 4.3 years to cover this distance. For humans like us, who exist in this universe for just a few moments, who are bound to our slow spaceships, this challenge becomes even greater for us. Reaching Proxima b is not just a journey, it's like making a bet with the impossible. So then why do we dream of Proxima b? Maybe because it's a mystery waiting to be solved. A piece of the puzzle that fits perfectly into the grand narrative of our existence. But before we set foot on this unknown land, we have to face a harsh reality. A reality that asks us questions we might be afraid to face. Set foot on an unknown land? Just think about it. The distance to Proxima Centauri is 266,000 times greater than the distance between Earth and the Sun. It's about 103 million times greater than the distance between the Earth and the Moon. Voyager 1, which is humanity's fastest interstellar spacecraft. It would take it 75,000 years to get there. 75,000 years by then, our civilization might have turned to dust. Or maybe we would have long forgotten that we ever launched probes called Voyager. The record-breaking Parker Solar Probe travels at 700,000 kilometers per hour. Even it would take 6,500 years to complete this trip. These numbers are not just scary. They remind us that, in terms of technology, we are still at a very early stage of development. Reaching Alpha Centauri is not a simple challenge. It will be a journey that demands breaking through and going beyond the limits of physics, engineering, and human imagination. And yet, as we gaze into this infinite universe, a strange question arises. Are we made to cross it or not? Does the universe have some secrets that perhaps we shouldn't unlock? If you have a strange question that arises, in 1905, Albert Einstein changed the way we understand our reality with his special theory of relativity. One of the many great mysteries of this theory was a bitter but clear truth. Any object that has mass will not be able to surpass the speed of light. This is not just a suggestion, it's a cosmic rule that cannot be broken, one that is forever embedded in the fabric of space-time. When an object accelerates, its energy turns into mass. The faster it moves, the heavier it becomes. Then a time will come when it will need infinite energy to go even faster. Just think about it. If an astronaut reaches 99.9% of the speed of light, his 80-kilogram mass will increase to almost 2 tons. The closer you get to the cosmic speed limit, the harder it becomes to increase your speed. Crossing the speed of light is like trying to jump over a wall of infinite height. No force, no power can take you to the other side. Even if we reach the speed of light, the journey to Proxima Centauri would still take about 4.3 years. But this is just a best-case scenario, a dream that seems almost impossible because of vast energy requirements and the laws of physics. Reaching such speeds is not just a technological challenge, it's a battle against the very nature and principles of reality, one that is impossible for us to win. A glimmer of hope, time dilation glimmer, and yet this universe is full of paradoxes. When a spaceship travels close to the speed of light, a strange phenomenon occurs. Time dilation. A spacecraft traveling towards Proxima Centauri at relativistic speed experiences time passing more slowly for its crew. For an observer on the ground, this journey may seem to last for decades or even centuries. But for the travelers inside the spacecraft, it will feel like only a few years. But time dilation is not just a subjective compression. Just think about a spacecraft that reaches 95% the speed of light. For an observer on Earth, the distance to Proxima Centauri, which is 4.246 light years away, will take about 4.47 years to reach. But for the crew, due to time dilation, this journey will feel like only 1.39 years. The faster the spacecraft travels, the smaller this difference becomes. But if the spacecraft travels at 99.9% the speed of light, then for the crew, a 1-year journey will feel like only 2 weeks. And if the speed reaches 99.9999% the speed of light, then a journey of thousands of light years would be completed by the crew in just a few decades, or even sooner than that. This phenomenon raises a profound question. Could relativistic travel open the path to interstellar exploration? Maybe, but time dilation is not a miracle. The energy required to reach such speeds is also unimaginable, along with the dangers involved, like collisions with high-energy particles, lethal radiation, and the dust of interstellar matter. At such speeds, even a thin layer of interstellar gas would turn into deadly plasma. For both the spacecraft and its crew, the empty space, which once seemed calm and completely empty, would become an invisible battleground. A battlefield where no spacecraft has survived yet. Time dilation does promise to take us to distant stars, but it also brings with it deep and mysterious barriers. Limitations of time dilation. As we saw earlier, to take a mass close to the speed of light would practically require infinite energy. So far, we haven't found any propulsion system that can make this possible. And even if somehow this energy problem is solved, even then, a spaceship traveling close to the speed of light would make space a very dangerous place. Space is not empty. In fact, it is filled with countless wandering atoms. Sometimes these gather in complex forms as gas and dust clouds, galaxies, stars, and planets. And sometimes they wander alone as atoms in this infinite universe. The probability of a collision between two hydrogen atoms in a cubic centimeter of space is a different matter. And the certainty of an enormous flow of particles colliding with the spaceship during its journey is an entirely different matter. At low speeds, the particles are harmless, but with acceleration, they rain down like a dangerous shower. As projectiles and highly penetrating ionizing radiation, they can cause severe damage to the spacecraft, and the atmosphere inside the spaceship becomes extremely radioactive for the crew living inside. Such particles that travel at speeds close to the speed of light acquire so much energy that they become a threat to any form of life. At such high speeds, even passing through a very thin nebular cloud can destroy the entire spaceship. Social and temporal disconnection, a lonely future. Even if we overcome all the technical challenges, there will still be an impossible problem left. Time dilation will have a devastating effect on the relationship between the spaceship and the home planet. For the crew aboard the relativistic ship, time will slow down significantly, but on Earth, the clock will keep ticking at its usual pace. The time that will feel like just 11 years for the crew, that will turn into millions or even billions of years for the people left on Earth. This harsh truth presents us with an existential dilemma. Astronauts who embark on such a journey will have to leave behind their world, family, friends, and even their culture forever. And when they return, Earth will have completely changed for them, or perhaps it might not even be habitable anymore. The society they once left behind will have been lost in the sands of time. Either it will have transformed into some alien form, or it will have completely disappeared. The spaceship will no longer be a means of exploration, but will become their own small world, drifting alone through time and space. The effects of such temporal isolation can also be seen in the idea of the fictional United Federation of Planets, like in Star Trek. The cultural and technological synchronization necessary for trade and cooperation would break down. Would a commercial enterprise have the motivation to send cargo on a journey where there would never be any connection with the sender again? Such a journey would not be a transaction but rather cargo that has neither an owner nor a destination. Under the rules of Einsteinian relativity, any spaceship embarking on such a journey would actually become a self-sustained world. Completely different from its origin, wandering away from its purpose. So, would this sacrifice be worth it?